Alright, this is Honors Geo Chapter 8, Section 1. Finding polygon angle measures in a polygon. So, let's suppose we have a triangle. A quadrilateral. Pentagon. Remember, pentagon has 5 sides. That's good enough. Okay. In terms of the sum of the interior angles, we know from the triangle angle polygon sum theorem that if I add all the angles in here, that I would get 180 degrees. Right. So if I was to sort of chart this, right, this would be my shape. We'll call this n number of sides. We call it angles, and sum of the angles. Sum of the angles. So for a triangle, we have 3 sides. We have 180 degrees. Here we'll put equation. So we have let's say one triangle times 180 degrees. If I look at a rectangle, I can create a diagonal within the rectangle such that I have 2 triangles. I have 2 triangles. If I only drew one diagonal to connect these 2 guys, that does not intersect. Diagonals cannot intersect, so I can only draw one diagonal. I would have 2 triangles. And I have 2 triangles that are both 180 degrees. So if I think about a quadrilateral, I have 4 sides. And if I was to add these 2 triangles together, 180 degrees plus 180 degrees, I would get 360 degrees. And I could think of it as 2 triangles times 180 degrees to get the sum of the interior angles of a quadrilateral. And if I think in terms of a pentagon, I can have a diagonal from here to here, and I can have a diagonal from here to here. And I would have 1, 2, 3 triangles, all at 180 degrees. So for a pentagon, I have 5 sides. And the sum of the interior of a pentagon is 540 degrees. And I could think of that as 3 triangles times 180 degrees to get the total sum. Hopefully you guys are starting to see a pattern here. And if I was to have a hexagon, if I have a hexagon, I would have 1 triangle here, 2 triangle here, or 2 diagonals, and then 3 diagonals here. And I would have 1 triangle at 180 degrees, 2 triangles at 180 degrees, 3 triangles at 180 degrees, and 4 triangles at 180 degrees. Alright, so then for a hexagon, I have 6 sides. At 720 degrees. And that would be the same as multiplying 4 triangles times 180 degrees. So for any polygon, and let's say the number of sides is going to be n, we would have the sum of that be the number of triangles times the sides. If you look at this, if I have my sides n and I have 4 triangles, I could think of that as 6 minus 2 equals 4. If I have 5 and I have 3 triangles, I could think of this as 5 minus 2 equals 3. If I have 4 sides and I have 2 triangles, I could think of that as 4 minus 2. If I have 3 sides and then 1 triangle, I could think of that as 3 minus 2. So when I think of my equation and I'll write it down here, to find out the number of interior angles of any polygon, it's going to be the number of sides minus 2 times 180 degrees. That is the first theorem of the day, the Polygon interior angles theorem, which says the number of sides, n equals sides, minus 2 times 180 gives you the sum of the interior angles of any. They use the word convex polygon. And remember, convex just means that there is no, here's a concave polygon. 1, 2, 3, 4. Right. There's no side where one of the sides goes inward in on itself, right? They are completely one-sided. Okay. So polygon interior angles theorem. Sum of interior angles of a polygon equals n minus 2 times 180 degrees. Then we have a corollary to that, And the corollary is just talking in terms of quadrilaterals. And the corollary to go polygon interior angles says that for quadrilateral, sum of the interior angles of a quadrilateral is 360 degrees. Jesus. It's 360 degrees. So here we have this coin that has 11 sides. They want to know what the sum of the measure is. So this is an 11-gon. So that means the number of sides, and I didn't really explain. So n means sides, number of sides. So in this case, n equals 11. So we use our equation, n minus 2 times 180, which is 11 times 2, minus 2 rather, times 180, which is 9 times 180, which is 1,620 degrees. When I add up all the angles within an 11-gon. Number 2 says that the sum of the measures of an interior angles of a polygon is 1400. How many sides does it have? So using n minus 2 times 180, we already know it equals to the sum of 1440. So I'll just divide 180 from both sides. Give me 8, then I add 2. So then n is going to equal 10. 10 sides. Okay, so I can use the polygon interior angle theorem to find the sum of the angles, or I can find it to use, if I'm given the sum already, to find the number of sides. We have this polygon here, and they want us to find out the measure of T and S. We have 1, 2, 3, 4. We have 5 sides, so it's a pentagon. So for number 3, we have that n is equal to 5. So I'll find the total number of interior angles by subtracting 2 from that times 180. And that's 3 triangles times 180. And I have a total number of 540. After I get that, I have enough information to find out what T and S is. I'll say that angle T is equal to X. Okay. Angle T is equal to angle S. We can say which is equal to X. We'll say it's X. So if we add them all up, X plus 9 to 3 plus 156 plus 85. That'll give me 540 degrees. And I just combine like terms. So that gives me 2x plus 334. And that's going to equal 540. Subtract 334 from both sides. And I get that 2x is equal to 206 divided by 2x is equal to 103. Okay. So angle S and angle T both equal 103 degrees. Alright, for this one they say we have a quadrilateral and they want to find the fourth angle, and we already have the 3 right there. So to find the quadrilateral, we would just say x again, plus 89 plus 110 plus 46, and I know that the sum of a quadrilateral is 360 degrees, 2 triangles times 180. Combine like terms, x plus 245 equals 360 degrees. Subtract 245 from both sides, and I get that x is equal to 115 degrees. Exterior polygons. So let's say I have a quadrilateral, and this works for any polygon, no matter how many sides. Let's say this quadrilateral is a rectangle, so these guys are 90 degrees. And let's say this rectangle forms linear pairs, right, with the other guy here. So this is an exterior angle, right, and it forms a linear pair. This guy is 90 degrees. I have another exterior angle this way that forms 90 degrees, forms a linear pair with that guy. And by the way, each one has 2 linear pairs, so I could go this way too and this way if I wanted to. I have this guy that forms a linear pair, and I have this guy that forms a linear pair. These are all exterior angles, right? These guys are both exterior. All 4 of them are all exterior angles. And they just form a linear pair with the angles inside of the polygon called interior angles. And if I was to add all the exterior angles of a polygon, so in this case, it would be 90 plus 90 plus 90 plus 90, so 4 times 90, I would get 360 degrees. And in fact, if I was to add any exterior angles of any polygon, it would give me 360 degrees, such that it will give me my polygon angle sum theorem. Exterior angle, actually. Polygon exterior angle theorem, which says that the sum of the exterior angles of the polygon equals 360 degrees. Okay. Notice it says here 1 angle at each vertex, and what does it mean by 1 angle at each vertex is that I could have 2 exterior angles. This is also an exterior angle. This is also an exterior angle. So I can only choose one of the two exterior angles when I do this. Otherwise, I would not get 360 degrees. I would get something different, and we don't want that, do we? So it has to be one of the two. Every side, every interior angle has two exterior angles. You choose one of them, and when you add all the exterior angles from one of the two, then you will have 360 degrees. All right, so we have a hexagon has exterior angles of that and that. So what is the measure of the sixth side? So I know that all the sums equal 360 degrees. They give me the 5, so 34 plus 49 plus 58 plus 67 and 75. Combine the like terms. And I get x plus 283 equals 360 degrees. Divide I subtract out the 283 from both sides. And I get that x is equal to 77 degrees. Alright. They don't specifically write the equation down here in this section, but there's two other equations. The other equation is if we have a regular polygon. So if we have a regular polygon, and we've had this definition before, a regular polygon is a polygon that has two conditions. Condition number one, all the angles are congruent. Condition number two, all the sides are congruent. Okay. So regular polygon, all the sides are congruent, all the angles are congruent, and that's really, really helpful if we want to find the interior angle of one regular polygon. So for regular polygons, you can find the interior angle for one by dividing n minus 2 times 180, dividing that by the number of sides. N minus 2 times 180 divided by the number of sides. That gives you one interior angle of a regular polygon. N minus 2 times 180 times the number of sides. So in this case of the example here, they give us, actually I'll use another one. Right. That's one equation. The other equation is if I have a regular polygon, I can find each exterior angle if I know that it's a regular polygon by dividing, I know that the sum of exterior angles is 360 degrees, so I would divide 360 degrees divided by the number of sides. 360 degrees divided by the number of sides. And that's going to give you each exterior angle, or you could think of it as one exterior. And the reason why I know what it is because since they're regular polygons, all the angles are going to be the same. So I divided by the total number of sides. Here, I know all the interior angles are going to be the same, so I divided by the total number of sides. All right. So if I had, let's say, a 15-gon, and I knew that it was a regular polygon, then if I wanted to find what one of the angles was going to be, and since I know they're all going to be the same, it would be 15 minus 2 times 180 over 15, the total number of sides. So 13 times 180, that would be 2340 over 15. And then one angle would be 156 degrees. If I wanted to know what that exterior angle is, I can do two things. One of two things. I can either if I don't know how many one side is, I can do 360 divided by 15. That's going to give me the sides of one exterior angle, and that's 24 degrees. That's one way of doing it. Or I could just subtract that from 180, because I know that they form a linear pair. Right? They form a linear pair, so I know it equals to 180. So if I already know what this guy is, I can subtract 180 from that. So and I can get 24 that way as well. So those are the two ways that I can get interior and exterior angles. I could either subtract one or the other from 180, or I can use the n minus 2 divided by n to get the interior angle of one regular and 15-gon, or I can divide 360 by 15 to get the exterior angle of one regular, in this case 15-gon. Okay. All right. Well, that is this section. Hope you have a great rest of your day.